Welcome. Today, we're going to tell a story. It's the story of one single, brilliant idea that took AI from being this kind of clumsy, confused thing to the confident, almost human-like partner you see in tools like ChatGPT. It's a story about a massive bottleneck and the incredible breakthrough that smashed right through it.
So what is that secret, right? How on earth did AI get so good at language? How did it learn to talk like us? That's the big question we're going to unpack today. And the answer, you'll see, is surprisingly elegant.
Okay, just look at this comparison. On the left, that's how an older AI might have phrased something. I mean, you get the point, but it's clunky, right? It just doesn't sound natural. Now look at the right. Same idea, but it flows. It sounds like something a person would actually say. This huge gap in quality was the problem, and it all came down to a really deep limitation in how older AI was built.
And that limitation has a name: the bottleneck problem. For years, this was the thing that held AI back. It's why they were so bad at understanding long, complicated sentences. Imagine trying to listen to a long story, but by the time you get to the end, you've completely forgotten how it started. That's what the AI was going through.
And you know, the numbers don't lie. Look at this. For a short little 5-word sentence, these older models were champs, 92% accuracy. Great, but watch what happens. You stretch that sentence out to 30 words, and the performance just falls off a cliff. It plummets to under 50%. The models were literally losing the plot because they were trying to squish the meaning of the entire sentence into one tiny fixed-size box.
And this image just nails the problem, doesn't it? The AI on the left is totally overwhelmed, trying to give every single word the same amount of importance. It's just lost in the noise. But the AI on the right? It's calm, it's focused. It's learned a new trick: how to shine a spotlight on only the words that matter. But before we get to how it learned that, scientists needed a way to measure just how confused the old AI really was.
Which brings us to our next part, actually measuring all that confusion. I mean, you can't fix a problem if you can't measure it, right? Researchers needed a score, a number that could tell them, okay, the AI is this puzzled by this sentence, and that score is called perplexity.
The best way to get your head around perplexity is with the shopkeeper analogy. Imagine you walk into a store and ask for a screw. Shopkeeper A is completely baffled. He just starts listing every single screw in the building. That's high confusion, high perplexity. Then you go next door to shopkeeper B. He listens, understands, and says, you need one of these 3. That's confidence, that's low confusion, low perplexity.
So, at the end of the day, that's all perplexity is. It's a number that tells us how surprised a model is when it sees a new sentence. A model that isn't very surprised is like that confident shopkeeper. It's really good at predicting what word is coming next. And in the world of AI, a low score is the holy grail. That's what you're aiming for.
So how do they even calculate this? Well, the basic idea is that the model reads a sentence one word at a time, and for each word, it tries to guess the probability of that word appearing based on the words that came before it. Let's just quickly walk through it.
First up, the model is looking at a totally blank slate. It has to guess the very first word. Based on all the billions of sentences it's been trained on, it might figure the word I has about a 20% chance of starting the sentence. So, probability, 0.2.
Okay, now it knows the first word is I. So what's a likely next word? Like is a pretty good bet, right? So it gives that a much higher probability, maybe 50% or 0.5. It does this for every single word in the sentence. Then it mashes all those probabilities together into that one final perplexity score. And that score gives the researchers a perfect report card for the model's confidence. So now they could measure the problem, and they could focus on a solution. And this is where the story gets really cool. Because the answer wasn't in more data or faster computers. The answer was found by looking in the mirror, by studying our own amazing brains. Just take a second and read this wonderfully chaotic little note. It's all over the place, isn't it? But for you and me, it's totally understandable. If I started asking you questions about it, your brain would do something incredible, and you probably wouldn't even notice it happening. Think about it. If I ask you, what fell in the tea, does your brain start at the beginning and reread every word? No way. It instantly jumps right to jam fell. If I ask where it's going to be thrown, your brain zips to throw it in the sea. You don't process everything, you zero in on what's relevant. And that ability, that superpower we all have, is called selective attention. It's this powerful, almost unconscious idea that we don't treat every bit of information equally. We just know what to focus on and what's just noise. And this was the exact skill that AI was missing.
So, that was the next monumental challenge:
How do you teach a machine to do that? How do you write code that creates its own spotlight of focus? Well, the answer came in a mechanism that would completely change the game for AI.
Let's break it down with an analogy we all get. Searching on YouTube. When you type something in the search bar, that's your query. It's the question. The list of video titles that pops up, those are the keys, all the potential answers. And the one video you actually click on and watch, that's the value, the real information, the meaning you were looking for. The attention mechanism basically does the same thing inside a sentence with digital queries, keys, and values. And here's what that looks like in action. To understand the role of the word Earth in this sentence, the model learns to shine its attention spotlight all the way over to the word visits. It figures out that the most important connection for Earth isn't the word right next to it, but the action that's happening to it, even if it's words away.
And let me tell you, giving AI this ability to focus didn't just cause an improvement, it sparked a full-blown revolution. This one single mechanism, attention, unlocked a future for AI that people had only dreamed of. And things happened fast. I mean, incredibly fast. In 2017, the landmark paper Attention is All You Need came out. Just 1 year later, models like BERT were using it to understand context like never before. 2 years after that, GPT-3 scaled it to mind-boggling size. And now? Today, this attention mechanism is the beating heart of pretty much every advanced language AI you can think of.
And if you need one picture to understand the impact, this is it. This graph says it all. The old models were just kind of inching along, making slow progress. And then, boom. The new transformer architecture, built on attention, just shoots for the moon. The performance goes exponential. This was the moment AI truly began to understand us. So what did this new approach really give us? Well, 3 huge things. First, it was way faster, because it could look at all the words in a sentence at once. Second, it gave AI real context awareness. It could finally understand that the bank by a river is different from a bank where you put your money. And finally, it completely solved that old bottleneck problem, connecting ideas no matter how far apart they were. So if you remember one thing from all this, let it be this. The breakthrough wasn't about more power. It was about focus. It was about taking AI from having this blurry, unfocused view of the world to giving it a targeted, precise spotlight. It was about teaching a machine to do what we do every second of every day. Pay attention.
And that leaves us with a really fascinating thought to end on. Now that AI has learned this incredibly fundamental human skill of focus, it really makes you wonder, doesn't it? What new, complex, and amazing things is it going to learn to see next?